Looking at the top one, these are both the last type of topics that we had done on Tuesday. They both dealing with fractions. This is with monomials, single terms, everything is connected by multiplication, but we have some negative exponents. And this is dealing with rational expressions or fractions that have polynomials in them. Looking at the top one, if you recall what I said you should do, you first have to try and get rid of the parentheses if you can. And since this -3 exponent is on the outside, it means that it must apply to both of these variables. So I'm going to first do x squared to the -3. So 2 times -3 is -6. And remember, when there's no exponent, it's understood to be 1. So 1 times -3, so we're getting y to the -3. The denominator was just x to the -4. So first, let's get rid of any parentheses that we see. After that, we start looking at our exponents, remembering that a negative exponent is telling us that you have to take the reciprocal. Now, what does a reciprocal mean? It means that you're taking something that's in a numerator and moving it to a denominator, and anything that's in a denominator, you're moving it up to a numerator. So if I'm going to deal with each of these things individually, here's my fraction line. I'll first look at the negative x to the -6. Since it's negative, it's got to be moved to the denominator. The y to the -3 also has to get moved because it has a negative exponent. Notice when I move it that I make the exponents positive. The x to the -4, which is in the denominator, also has to get moved. It gets moved to the numerator. Remember, only move those things that have negative exponents. And then your final step is to try and, first of all, combine anything on the numerators and anything the denominators if it's possible. There's nothing to combine. And then to reduce your fraction by canceling out like factors from the numerator and the denominator. Now there's an x to the 4th in the numerator and an x to 6 in the denominator. Remember, you always cancel out the one with the lower exponent. So the x to the 4th gets canceled out. And you do 6 minus 4, and it'll leave you x squared in the denominator. Now, since there's nothing left in the numerator, I have to put a 1 there. It's not empty. It's not a 0. Your final answer should have been 1 over x squared y cubed. That's in the simplest form. It has no negative exponents. It's reduced as much as it possibly can. So that takes care of question number 1.
Yeah, I forgot about the number 1 on top. Sorry about that.
So that's something that you really have to, and it's usually used as a trick. But just think, there's a very big difference. Let's say you had money. There's a very big difference between a $1/5 and a $5. So make sure if the 1 is in the denominator, you don't have to put it in. But if the 1 is in the numerator, if everything disappears from someplace, you have to put a 1 there. Again, if everything in the denominator is a 1, you don't have to put that in, but it may make sense just to do it to get the practice. Okay, let's look at the second question, because this is where we're really going to be starting now. What do we do when we have fractions that consists of polynomials in the numerator and or the denominator? Well, we also want to reduce or simplify those fractions. And in order to do that, we have to find the common factors. Now, over here, it wasn't so hard to find factors because everything was connected by multiplication. But as soon as you have pluses or minuses in between your terms, the first thing you're going to do is to have to factor. So if we look at the top trinomial, I'm going to have to use our AC method of factoring these. There's no common factor here, but my AC, let's do the top one. The AC is going to be 15, and the B is going to be -8. I'm going to do the top one over here and the bottom one over here, and then I'll put it all together. So when we want to factor this, we're looking for two numbers that are going to multiply to 8, but add to multiply to 15, but add to -8. Since it's multiplying to positive number, they're either both positive or both negative, but this -8 is indicating they're both negative. It's obviously -3 and -5. So I'm going to rewrite this is x squared minus 3x minus 5x plus 15. Notice it's very important that you know how to factor. And I'm assuming that at this point you really can do the factoring. Remember, in our first group, we have a common factor of x, so that's x minus 3. And in my second group, I have a common factor of -5 because it's starting, the 5 goes to both of them and it starts with a negative. So this is going to give me x, and -5 into positive 15 is going to give me -3. So my numerator turns out to be x minus 3 on the outside and x minus 5. Those are my two factors over here. Now let's work on the denominator. Do that over here and we'll put it over here. You really sort of need a lot of space for these problems because you need to work on the factoring separately and then to work the problem. Over here for the denominator, the AC is 1 times -10, which is -10, and the B is -3. So we're looking for two numbers that are going to multiply to -10, which means obviously one is positive and one is negative. And when we combine them, we're going to get -3. So obviously that's a -5 and a +2. I think that you could have done in your head as well. So this is going to give you x squared minus 5x plus 2x minus 10. -5 and +2 is giving me -3. So this is my x times x minus 5 for the first group. And for my second group, it's a +2 times x minus 5. So that'll give me x minus 5 times x plus 2. This is the hard part of the problem, doing the factoring. You have to really be proficient at factoring because all the problems will involve factoring. Once you've got your factoring, then you look at your example. You can only cancel out factors, like factors. That means whole parentheses. So first factor I see is x minus 3, but there's no x minus 3 in the denominator. The next factor I see is an x minus 5. And there is an x minus 5 in the denominator. I can cross them both out. It isn't so necessary to put the 1 there in this case because there are other things left. So you won't make that mistake. There's nothing else to cancel out. So your final answer comes out to be x minus 3 in the numerator over x plus 2 in the denominator. Now notice I didn't bother putting in the parentheses because they're only single polynomials. There are only one binomial on the top and one binomial on the bottom. We only use those parentheses to separate the two binomials. So you can either put it with the parentheses or not, but this is the way the answer is going to be given. Is there any question about that? All right. So let me just stop here and just remind you. We're going to be continuing with this. Don't forget, some of you I see have already done it, but I posted on Blackboard the test that's called Test 1 for Blackboard. It actually is the second test this term, but the first test was on Delta Math. This is the first test that we have on Blackboard. It consists of 20 multiple choice questions. It's essentially like the midterm. It's really a practice midterm as well, but I'm using it as a test. You have until next Tuesday at 10 o'clock to complete this test. Don't think that you can start sitting down to it at 10 o'clock next Tuesday. It has to be completed by then. I gave you 70 minutes to do the test. Once you sit down to the test, you must complete it. You must complete it in one sitting. You can't do 5 problems and then take a coffee break and think that you can then come back. If you closed your computer at that point, it automatically submits the test, and that's it. If you have a problem with your internet and it shuts off, it will automatically submit your test. If that should happen to you, if you have a problem or for some reason it freezes up, send me an email. As soon as I see the email, I will reset the test. Unfortunately, in Blackboard, I can only reset the whole test. I don't have the option of resetting. Let's say you got to question 10 and then the whole thing shut down. You're going to have to start the test from the beginning, but I will restart the test for you if you have any problems. I would suggest as a result, don't leave it to the last minute, because I'm not sitting and looking at my computer every minute. If I know I was just giving the test over a 3-hour period, I would sit with my computer open, but otherwise I will periodically through Tuesday look on the computer and check that nobody's having any problems. And somebody actually did the test in the other class and they did get shut out, so I reset it for her. That's good. So look out for that problem. But again, allow yourself the full amount. Don't think you have, I have a half an hour free, so I'll just start the test. It doesn't work that way. You have to do it and sit and do it all in one setting. Okay, let's now go on to what we were talking about. I want to do a problem and show you something that we have to be aware of. Let's say I gave you this problem. Suppose I wanted you to simplify this fraction. 4x squared minus 9 over 6 minus 4x. And again, I want to simplify it. So in order to simplify it, I've got to factor first. And I don't have a trinomial on the top, I just have a binomial. There's no common factor there, but it is the difference of squares. So I can factor this to 2x plus 3 and 2x minus 3. Don't forget that that's a very common type of factoring you're asked to do, factoring out the difference of squares. In the denominator, we have a common factor of 2. So I'm going to put out 2 on the outside, and it'll give me 3 minus 2x. Now, normally I would say you can't reduce this any further. because you could only cancel out like factors. And there's a 2x plus 3 on the top. There's no 2x plus 3 in the bottom. There is a 2x minus 3 and a 3 minus 2x. And those look very similar, except they're in the opposite order. Now, let's think about what happens when we subtract and we change the order in which we're subtracting. Suppose I have 5 minus 3. I'm just doing it with regular numbers. Obviously, that will give me 2. Whereas if I do 3 minus 5, I'm not going to get the same answer. I will get -2. I actually get the same number, but a different sign. And that always works when you have binomials that are just switched in order with a subtraction in between them, with a minus in between them. If I have 12 minus 17, that gives me -5. Whereas 17 minus 12, the same binomial, the same two numbers, but switched order, gives me +5. Well, let's think about this. What if I have a -5 over a +5 in a fraction? Can we reduce it? We certainly can. These two numbers, I can divide both of them by 5. When I divide the 5 by the -5 by 5, I get -1 over 1, or my answer is just -1. In other words, if I have two numbers that are negatives of each other, they're the same numbers, but one is a positive and one is a negative, then it's possible to cancel it out in a fraction because you just get a -1 in your answer. How does this affect what we have over here? So let's talk about this. In the numerator, I have a 2x minus 3. In the denominator, I have a 3 minus 2x. Identical binomials with the order switch, not the sign switch, the order switch. Here I have the 2x first and the 3 second. Here I have the 3 first and the 2x second. I can cancel them out as long as I put a -1 in place of one of them. I don't put a -1 for both of them because -1 over -1 would be just +1. I put -1, and if I have a choice of where to put the -1, it's better to put the -1 in the numerator than in the denominator. It's not wrong in the denominator, but it's a better format to have a negative in the numerator rather than in the denominator. That would mean that my final answer over here would be -1 times 2x plus 3 over 2. If you wanted, you could distribute that -1. But what's usually done with it is when you have a negative in the numerator, this is indicating the whole numerator is negative, you could just put the negative sign in front of the whole fraction. And that's probably a better way to write the answer. A fraction can have a negative located in any one of 3 places. It could be in the numerator, it could be in the denominator, or it could be right in front of the fraction. That putting it right in front of the fraction is the better way to indicate it. So this is the one exception to our rule that you can only cancel out exactly alike factors. If you have binomials that look exactly alike except their order is switched, if there's a plus between them, you can just cancel it out. But if there's a minus between them, you have to cancel them out, but put a -1 in place of one of them. In other words, if I would have had something like this, 2x plus 3 on top and 3 plus 2x on the bottom, I can put them in parentheses, even though you don't need them. Notice these are actually identical, because when you change the order in addition, it doesn't change the value of the number. 2x was 3 and 3 plus 2x are identical. This is just plain 1. It's when you have a minus, like a 2x minus 3 and a 3 minus 2x, that you can cancel it out as long as you put a minus in place of it. Okay, I want to go on to another topic. And after that, I'm going to, if we do a couple of more problems, then I'm going to give you some to try. Okay, so let's look at this example. We talked about what's called reducing fractions or simplifying fractions. Now I'd like to talk about multiplying and dividing of fractions. Suppose I had, let's do it just with plain numbers. Suppose I had this 3/4 times 7/3. I want to multiply these two fractions. The basic rule for multiplying fractions is really quite simple. You multiply the numerators together, that gives you the numerator. Then you multiply the denominators together, and that gives you your denominator. So essentially, what we could do is just get 3 times 7 to get 21, and 4 times 3 to get 12. Of course, what we then want to do is reduce our fractions. Get our answer in simplest form. So once I've got my answer, I have to simplify the 21/12. And I noticed that both the numerator and denominator could be divided by 3. 21 divided by 3 gives me 7. 12 divided by 3 gives me 4. And my final answer becomes 7/4. That's the basic rule. But there is a step that we can take that involves simplifying the fractions before we do the multiplication. Here we did the multiplication and then simplify. A more efficient method is, and I'm going to show you. If I have something like 3/4 times 7/3, is to try to do something called cross-canceling first. In other words, first reduce and then multiply. How do we do that? Look at just go across your numerators. Your first numerator is a 3. Is there anything in the denominator, whether in the same fraction or the second fraction, is there anything that can cancel out with the 3? It has to be a numerator canceling with a denominator. It can't be two numerators. It can't be two denominators. It has to be a numerator with a denominator. And if you notice, this 3 can cancel out with this 3. Now I'm going to have to put 1s here because once everything disappears, I have to put a 1. The other thing I have here is a 7, and there's nothing to cancel out with a 7. Once I've done that, I can now multiply the numerators together, which will give me 7, and the denominators together, which will give me 4. And my final answer again is 7/4. But it was easier to reduce or cancel when the numbers were smaller than when they were bigger. So that's what's called cross-canceling. That's one thing we have to look out for. The other thing is when we have division. The only difference between multiplying fractions and dividing fractions is the first step. if you have um, 11/5 divided by 22/10, for example. Suppose you want to divide these two fractions. Yeah, these are done. The first step is to rewrite the problem by leaving the numerator, the first fraction alone, leaving it 11/5, changing the division to a multiplication, and taking the reciprocal of your second fraction, changing it to 10/22. Not the negative reciprocal. This is not perpendicular lines. All you do is whatever the fraction is, you flip it over. And then you have just a regular multiplication problem like we had before. Again, I'm going to try to cross cancel. The 11 here cancels into the 22. So 11 here, this will give me 1 and this will give me 2. This is a 10. The 10 and the 5 cancel, so I'll get a 2 here and a 1 here. And I can even go a step further because it can be any numerator with any denominator. This 2 can cancel with this 2. And my final answer is 1 times 1, which is 1/1 or just 1. If you didn't realize that, you might have gotten 2, or you could have gotten 1 times 2 is 2/2, but then don't forget that could be canceled down to 1. So that's the basic rules that we use in multiplying or dividing of fractions. So let's try an example that's a little bit on the more difficult side and see if we can figure out that example. Let's do this example. First, I'll do a multiplication, then I'll do a division, and then I'll give you one to try. Again, make sure you have a lot of paper. You want to give yourself room because if you do it messy, you're going to mess up. Suppose I have 3x minus 12 over x squared minus 4 times x squared plus 6x plus 8 over 4 minus x. Okay, this is a multiplication problem. And in this case, our fractions are made up of polynomials. So we know that we're going to try and factor everything first, see if we can cancel anything out, and then finally multiplying the numerators together and then the denominators. So in the 3x minus 12, we see that we have a common factor of 3. This becomes 3 times x minus 4. In the x squared minus 4, we don't have a common factor, but this is what we call the difference of squares. We can break this up into x plus 2 and x minus 2. Okay. Now we have the x squared plus 6x plus 8. Now that I'm going to do over here on the side. My AC is going to be 1 times 8, which is 8. And my B is the positive 6. So I'm looking for two numbers that multiply to 8, and add to 6. Well, obviously that's 4 and 2. In other words, we're going to write the x squared plus 6x plus 8 is x squared plus 4x plus 2x plus 8. And my common factor in the first group is x, so we have x plus times x plus 4. And in my second group, the common factor is 2, and we have the x plus 4. So writing that down, that's going to give me x plus 4 times x plus 2. Notice you should be pretty proficient at doing the relatively easy trinomial factoring. If there is a number in front of the x squared, that makes it a little bit more difficult, but you should be able to do something like x squared plus 6x plus 8 pretty quickly. And finally, there's nothing that I can factor here, so it becomes x minus 4. I have now done all the difficult work. The factoring is the difficult work. The next thing is the canceling, the cross reducing. So I start at the very beginning of my first numerator, and I have a 3. Now 3 happens to be a monomial. It doesn't have 2 terms, it's only 1 term. The only thing monomials can cancel out with are other monomials. There are no other monomials, so there's nothing to cancel out this 3 with. The next thing I see is an x minus 4. Now, don't make the mistake of trying to cancel out it with the x plus 4 for 2 reasons. The x plus 4 is also in the numerator. It always has to be canceling out a numerator with a denominator. And the only thing you can cancel out an x minus 4 is another x minus 4 or possibly a 4 minus x. And we actually do have a 4 minus x in the denominator. So I can cancel this out with this. I better put a 1 here and a negative 1 here. Notice I put it in parentheses to indicate that this is, I'm not combining 3 and negative 1, I'm going to be multiplying 3 and negative 1. The next thing I have is an x plus 4, but there's nothing in the denominator I can cancel out with x plus 4. Don't think you can try the 4 and the 2 and just get 2. It has, when it comes to binomials, they have to be identical. And then the next thing I have is an x plus 2, and I can cancel out the x plus 2 with the x plus 2. Notice I didn't have to put in the 1s there because there were other things left. Now I've done all the canceling. Now I'm going to write my final answer. First of all, 3 times negative 1 is negative 3. So I get negative 3 times x plus 4. And you can leave it in parentheses over x minus 2. That would be one way of writing your answer. Another way of writing your answer is when you have a negative that's multiplying the whole fraction, you could just put it in the front and you could do negative and then just do the 3 times the x plus 4 over x minus 2 like that. In other words, this negative happens to be a factor of the whole numerator. Or alternatively, you could have just distributed the negative 3 and you could have gotten negative 3x minus 12 over x minus 4. These are all 3 equivalent proper answers for this problem. I have a tendency to leave the thing in factored form. I usually don't distribute it because maybe I would want to do something. I like it in I think factored form is a simpler format, but this is not wrong. This is considered a very good answer. Okay, shall we do one more? Are you ready to try one on your own? I think you could try one. I'm going to give you one to try on your own. Okay, we have x squared minus 9 over x squared minus 10x plus 24 divided by 3 plus x over 10x minus 15. See if you could get, this is a division one, don't forget. I want you to divide this and get your answers in simplest, wait a second. I'm sorry, wrong denominator. Taking two different problems. This is 2x minus 2. Okay, while you're doing that example, I'm going to be reading the attendance. What's next to the 10x? It's 10x squared minus 10x plus 24. Is that clear? Okay, good, Adina. Maury Alabre. Hi, good morning. Good afternoon, actually. Chelsea? Chelsea here?
Present.
Oh, good. Thank you. Ariana,
Here, good afternoon.
good afternoon. Good to have you here. Adina, I know you're here because I've seen you Lachey.
I'm here.
Hi.
Hey.
Kava. Kava,
Here.
hi, how are you?
I'm good.
Good. Terrence,
Here.
hi. Karide, Karide here?
Here,
Hi. Kizia. Kizia here, Kizia Daniel. Faith. Faith Diggs. Ethan.
Here.
Hi. Isabella. Isabella. Serenity.
Here.
Reggie, I know you're here because
Here.
I saw you before, okay. Zamia. Zamia? Brandon,
Here.
hi. Michaela,
Here.
hi. Seraphine. Seraphine? Marissa?
Here.
Renee?
Here.
Hi, I think you were the first one on. Sky. Sky Powell.
Sky Powell is here.
Okay, good. Jaden Roberts. Kennedy Shelton. Kennedy,
I'm here. I'm here. Can you hear me?
okay, Sky, I see you're here. Is Kennedy here? Felicia Simon.
I'm here.
Okay, good. And I see Kennedy is also here. Natalia Small.
Here.
Hi. Michael Todd. Michael Todd here?
Here.
Cassidy Tucker. Cassidy? Hi. Megan?
Here.
Hi. Kalia Watson? Lauren Whaley.
Here.
Hi. And Kayla Zachary. Okay, Zamia, I'm changing you. Okay. Okay. I think I see some people have already put answers in, so let's see if we can do this together. We'd like to get our answer in as simplest form as possible. Again, in order to do that, first of all, I see this is a division. So it means that I'm going to have to take the reciprocal of my second fraction. So this is going to be x squared minus 9 over x squared minus 10x plus 24 times 2x minus 12. Taking the reciprocal of the second fraction over 3 plus x. Okay, now the next thing I have to do is try and factor everything so I can see what I can cancel out. So the x squared minus 9 factors to x plus 3 and x minus 3. It's a difference of squares. Okay, I'm going to go over here to do the x squared minus 10x plus 24. I'm going to do the work over here, and then I'm going to write it over here. Okay, so my AC for that one is 1 times 24, which is a positive 24. And my B is negative 10. So I'm looking for two numbers that will give me a positive 24 when I multiply. But when I combine them, will give me negative 10. Now, obviously, in order to get a negative, it either would be two negatives or two positives. Obviously, this has to be two negatives. And the two negatives are obviously negative 4 and -6, because -4 times -6 will give me 24, and -4 plus -6 will give me my -10. So rewriting this will give me my x squared minus my 4x minus my 6x plus 24. And my first group will have a common factor of x, so that'll give me x times x minus 4. And my second group has a -6 as a common factor because it starts with a negative and 6 goes into both of them, so that'll give me x. And 24 divided by -6 is -4. So that will give me x minus 4 times x minus 6 as the factors of x squared minus 10x plus 24. So let's write this, x minus 4 times x minus 6. Any way you can factor this, if you can see it in your head, you don't have to do this whole method. This method works on all trinomials, but some people can just see, oh, this is a 24, they need to multiply to 24, add to -10, it has to be -4, -6. If you don't have to write the whole process out if you can do it in your head. Okay, now let's go to the numerator 2x minus 12. That has a common factor of 2, so this becomes 2 times x minus 6. And the 3 plus x has no common factor, it just stays 3 plus x. And now we're ready to try and cross reduce. So I start with my x plus 3. There is no x plus 3 in the bottom, but there is a 3 plus x. Remember, we're always looking for the identical binomial or the binomial with the order switched. Since this is a plus, the x plus 3 and the 3 plus x just cancel out. I do not have to put a -1 here. When you're adding, it doesn't matter what order you're adding them in. 2 plus 3 is 5, 3 plus 2 is 5. It doesn't make a difference. It's only when there's a minus that it makes a difference. So that just cancels out. Now I have an x minus 3. There's nothing to cancel out with an x minus 3. Now I have a 2. There's nothing to cancel out the 2 with. The 2 is a monomial. It can only cancel out with another monomial. There are no other monomials. And then I have an x minus 6, and that can cancel out with this x minus 6. So if I look what I have in my numerator, I have an x minus 3 and a 2, which I can just write as 2 parentheses x minus 3. And in my denominator, I get x minus 4. It's perfectly okay to write the answer like this, leaving it in the fact, just putting the factors right next to each other. Alternatively, you could have written it as, you could have multiplied out the 2 and gotten 2x minus 6 over x minus 4. These are both good answers. And on a multiple choice test, again, this is not on our midterm or on our test. Our test, this is chapter 5, it's not on the test. But when it comes to the final, they could either give you this answer or this answer. They won't give you both because they're both perfectly correct. Let me see if anybody got this answer. Reggie, you see that you could have, you made it, you didn't cancel anything out, so therefore your answer was much more complicated. Adina, the same thing with you.
Yeah, I figure that.
Ariana got it right. What? You get it now?
Yeah.
Yeah, you're okay with it now? Good. I do see that some people did get the right answer, but you see how important it is to try and factor everything so you can do this canceling out before you do the multiplication or division, because it's so, otherwise your answers become very complex. and require a lot more work. So this is how we multiply and divide fractions. What I want to now start discussing is what happens when we have adding or subtracting of fractions. And I'm going to do it by just reminding you how to add regular fractions with regular numbers, and then so that'll leave us ready to go on to this topic on Tuesday. Usually when we teach things, we usually teach adding and subtracting before we teach multiplying and dividing. When it comes to fractions, we do it in the other order because multiplying and dividing is really simpler to do with fractions than adding and subtracting. In order to add fractions or subtract them, you have to have something called an LCD, a lowest common denominator. It's called the LCD. And essentially what the LCD is both fractions have to have the exact same denominator. You can't add or subtract fractions if they have different denominators. You have to get them to have the same common denominator. So let's say I have 7/5 minus, now let's do plus 13/5. Notice when we're doing these algebraic fractions, we're not going to care if the numerator is bigger than the denominator, what's called an improper fraction. Our answers can be improper fractions, our work can be improper fractions. That's usually the best way. We usually don't leave things as what's called mixed numbers, though that's something that you probably did in elementary school. But I'm going to remind you how you did this in elementary school. These two fractions actually do have this LCD, a common denominator. They both have a denominator of 5. If you have a common denominator, then you essentially ignore the denominator, just work with the numerators. Whatever the sign is, if this would have been negative, a minus sign, I would have subtracted it. This is plus, so I'm adding this. I do 7 plus 13, which gives me 20. Once I've combined them, I put that combined answer over the common denominator. So my final answer becomes 20/5. What I then try and do is try and simplify the answer. See if you could reduce the answer. In this case, we can, because the numerator and denominator are both divisible by 5. So 5 divided by 5 is 1. 20 divided by 5 is 4. This becomes 4/1. Remember, when the 1 is in the denominator, you could just write the number without it. If the 1 is on top, you have to put it in. If it's on the bottom, you can just leave it out, because 4/1 and 4 mean the same thing. So that's how we add or subtract fractions that have the same denominator. Let's try an example with polynomials and with algebraic fractions, rational expressions, as we call them. I'll do one and then I'll give you one to try. Suppose I gave you this example, 2x minus 5 over x minus 2 minus x minus 3 over x minus 2. Now, in this case, I want to subtract the fractions. But remember, with both adding and subtracting of fractions, you must have a common denominator. And luckily, we do have a common denominator. The two denominators are the same. They're both x minus 2. So what we do is, once we have the same common denominator, we just work with the numerators. What we want to do is the 2x minus 5 minus, we want to subtract that whole second fraction, x minus 3. Notice I had to put it in parentheses because I don't want to just subtract the x, I want to subtract the whole x minus 3. Now, if you remember, this is as if there's a -1 in front of it, and this becomes 2x minus 5 minus 1 times x is minus x, and minus 1 times minus 3 is plus 3. You could have also done it in your head. You were subtracting x, so that became minus x, and a minus 3 gives you a plus 3. Now combine your like terms. So I have 2x minus x, which gives me x, and -5 plus 3, which gives me -2. Once I've combined the numerators, I put it back over the common denominator. So my answer becomes x minus 2 over x minus 2. Remember, after I've done that, after I've combined them, I then see, can I reduce this fraction? And yes, this can be reduced because I can divide top and bottom by x minus 2. So this will give me a 1 on the top, a 1 on the bottom, which is 1 over 1, or just 1. Your final answer is 1. So when you have the same denominator in both fractions, you just work with the numerators. You either add them or subtracting, depending on what the operation is. And after you've combined all the like terms, then you go ahead and put it over the common denominator and see if you could simplify the fraction. Let's see if I can give you one to try. Suppose I gave you this example. I'm sorry. Okay, suppose I have on y plus 4 over y squared minus 16 minus 2y over y squared minus 16. And I want you to subtract these two fractions. I'm going to give you a few minutes to try that. Okay, we have somebody who has an answer ready, so let's see if we can do this together. First of all, I see that I have a common denominator. It is y squared minus 16. Both of them have the same common denominator. So we just have to work with the numerator. So we have 4 plus y minus 2y. And I have to put a parentheses here because it's only one term. When I combine the 4 plus y minus 2y, I get 4 plus y minus 2y is 4 minus y. So my numerator comes out to be 4 minus y, and I put it over the y squared minus 16. Remember, I only start to simplify after I have combined all the like terms. I can't factor the numerator, but the denominator does factor. It's the difference of squares. This becomes 4 minus y on top, and y plus 4 times y minus 4 in the denominator. And the 4 minus y and the y minus 4 cancel out as long as you put a -1 in place of the numerator. We prefer to put it in the numerator because they're the same binomials with opposite signs. So the final answer is -1 over y plus 4. And again, you could write it this way, or you could write it with a negative in front. But don't forget that 1 in the numerator. Don't write it y plus 4. This is 1 over y plus 4. So that's, and I think that is the answer. Like, both people got that answer. It's y, not x, but that's fine, Ariane. I could do that also. I could change the sign, the letter by mistake. Beautiful. You both did it correctly. glad to see that. So I just want to prepare us for the next thing that we're going to be doing. And that's what happens when my fractions don't have a common denominator. Does that mean we can't add them? Of course it doesn't. What we have to be able to do is to figure out what the LCD is and change our fractions to that LCD. And in order to do that, I'm going to show you how I would do with numbers, just as a reminder. And then we will then go to, okay, in answer to your question, let me just answer the question, Zamia. If you noticed, this didn't say y minus 4. We had a 4 minus y over a y plus 4 times a y minus 4. The y minus 4 and the 4 minus y were almost identical. The difference being that the order was different. When the order is switched with a negative sign, then it means they're opposite signs and you have to cross them out using a -1. When there's a plus in between them, if it would have been 4 plus y and y plus 4, that when you're adding, it doesn't matter what order you're adding them in, and therefore it's the same thing. So you get a -1 when you have the order switched with a minus. You have a +1 when the order is switched, but they're both pluses. Does that answer your question? All right, so now let's just look at how we would add two fractions, regular number fractions. You should remember this from probably 5th or 6th grade, but I'm just reviewing it so that when we get to our rational expressions, we'll be able to figure out what to do when our fractions don't have the same common denominator. Okay, so let's say I wanted you to add the fractions 5 over 6 with 7 over 8. Now the problem is they have different denominators. What we're going to try and find is a number that both of these two numbers will go into. And in other words, what's called the least common multiple, the LCM, the least common multiple. Now, one way of going about it, we'll do it one way with just plain numbers. When we have actually polynomials, I'm going to show you a slightly different way to do it. But what I usually do is I start with the largest denominator, which in this case is the 8. And see if the other denominators divide into it. The 6 divide evenly into 8. No, 6 is not a multiple of 8. 6 does not go into 8. So let's do 8 times 2. That'll give me 16. Does 6 divide evenly into 16? And the answer is no. So let's try 8 times 3. 8 times 3 is 24. Does 6 divide evenly into 24? And the answer is yes. 6 is a multiple of 24. 8 is a multiple of 24. 6 times 4 is 24. 8 times 3 is 24. Your LCD then is going to be 24. We're going to change each of these fractions to fractions with denominator 24. Now, how do we change a fraction? Fraction is different than regular numbers. A regular number, like if I have a number 5, and I'm just dealing with whole numbers, the only thing 5 can be is 5. But when we're dealing with fractions, there are many different versions to the same fraction. In other words, we can have 1 over 4, 1/4 is 1 name for a fraction. 2/8 is the same fraction. 3/12 is the same fraction. There are many names to the same fraction. We're going to rename each of these fractions so that their denominator is 24. And the way we do it is we figure out what we multiplied the denominator by and use that same number to multiply the numerator. We want to multiply the numerator and denominator by the same number in order to not change the value of the fraction. So I divide the 6 into the 24. That gives me 4. In other words, I went from the 6 to the 24 by multiplying by 4. So I have to take the 5 and multiply by the 4 as well. And that'll give me 20/24. Notice 20/24 does reduce to 5/6. I only want it in this format so it can have the same denominator. We do the same thing with the 8. 8 into 24 gives me 3. I multiply the 8 by 3 to get 24. So I have to take the 7 and multiply it by the 3 as well. And that'll give me 21/24. And now that I have a LCD, I have the same common denominator. I do what I did before. I take the numerators. This is a plus, so I'm going to add them. 20 plus 21 will give me 41. And I put that over the common denominator. Notice I've only worked with the numerators. And then I try to reduce this fraction. If you notice, it's not reducible because 41 happens to be a prime number. There's nothing that goes into both 41 and 24. So this is my final answer, 41/24. So next time, what we're going to be doing is we're going to be, first of all, reviewing for the midterm. I will look at your tests that you're taking on Delta Math, and I will pick out the questions that people had the most trouble with. If you have any questions that you want to ask me, remember you will have to have submitted it by then, but I will go over anything that you have questions on. So part of Tuesday, that's the 19th, is going to be review. The other part, we're going to continue with our discussion of adding of fractions, adding of rational expressions, adding and subtracting. We haven't done those that don't have common denominators. We're going to work on that on Tuesday. Don't forget over the weekend, I probably will assign some homework on Delta Math, so look out for that. Does anybody have any questions they want to ask me? Okay, so don't forget the test to go to your Blackboard account and go into the tests and quizzes section, and you'll see test 1 for Blackboard right there, and it's a multiple choice. You put your answers right there. You pick the correct answer. It's pretty self-explanatory. If you have any problems, if your internet freezes up or anything of that nature, send me an email and I will reset your test for you. Remember, this is good practice because this is the way your midterm and your final is going to be given as well. I don't know if you recall, I mentioned if you do better on the midterm than you do on this test 1, I will enter as your grade for test 1 the mark that you got on the midterm. I'll take the better grade and use that as your grade for test 1. Your midterm mark is going to stay your midterm mark. Again, if anybody has any questions, you can either email me or ask me next time in class. Have a good weekend.
Bye, Professor. Have a good one.
Thanks. Bye-bye. I'm ending the session.